For this skill, we'll be looking at rational versus irrational numbers and simplifying radicals. So first, let's discuss the difference between rational and irrational numbers. I'm going to start with irrational because if there's only two different options when it comes to what makes a number irrational. And then pretty much if it's not irrational, it has to be rational. So a rational number is the number that is expressed as the ratio of two integers, where the denominator should not be equal to 0. While irrational is a real number that cannot be expressed as a ratio of integers. So let's look at the two options when it comes to an irrational number. It's either a decimal, where it never ends. Notice that they have a dot to end. It never ends and it has no pattern. That's what makes it irrational. Or if you have a square root of a number that's not a perfect square. All right, like the square root of 2, square root of 3, square root of 5. All right, like if you simplify the radical and you still have a radical in your answer, that's irrational. If you look at a decimal and it keeps going forever and it has no pattern, that's irrational. Everything else is irrational. So if it has a decimal but it has a pattern, that's rational. If it has a decimal and it just terminates, it has no pattern but it just stops at one point, that's rational. If it can be written as a fraction or a whole number, that's rational. And if it's a square root of a perfect square, like 11 times 11 is 121. So square root of a 121 is equivalent to 11. So because that's a perfect square, that's a rational number. It can be written as a whole number. So these are 6 very famous statements that you often see on an assessment when they're asking you about rational versus irrational numbers. So let's look at the first one. The sum of a rational number and a rational number is rational. That is always true. All right. You have a rational number plus another rational number, you get a rational. All right. When you have a sum of a rational number and an irrational number, that is irrational. That's always the case. All right. If you add rational numbers together and they're both rational, the answer is rational. If you add a rational with an irrational, it's going to end up being irrational. Now see, the sum of a irrational number and an irrational number is irrational. Sometimes true. Because think about it. Negative square root of 3. That's an irrational number. Square root of 3 is not a perfect square, so that's an irrational number. Negative square root of 3 plus a positive square root of 3 is 0. That's a rational number now. All right. So it's not always the case. All right. Most of the time, but not all the time. Now for D, the product of a rational number and a rational number is rational. That's always true. The product of a rational number and an irrational number is irrational. That's sometimes true. Because think about it. Let's use square root of 3 again. That's an irrational number. You multiply it by 0, you get 0. So an irrational number times a rational number can give you a rational number. All right. So it's sometimes true. It's only when you have multiplied by 0 is when this situation is not the case. But that's only one situation is enough for you to say it's sometimes true, not always. And the last one, the product of an irrational number and an irrational number is irrational. Another one that's sometimes true. Because let's go back and use square root of 3 again. If I took square root of 3 and I multiply it by square root of 3, the two irrational numbers, I multiply it together, I get square root of 9. Square root of 9 is just 3 without the square root at all, which is a rational number. So now let's look at some simplifying radicals. So when you simplify a radical, you want to be able to take out the largest perfect square that can go into the number under the radical evenly. So if I look here at 180, 36 is the largest perfect square that can go into 180 evenly. 36 times 5 gives you that 180. So then now from here, you say, what is that square root of 36, which is 6? So then I can take it out from underneath the radical. All right, every perfect square, I can take it out and take the square root of it and write it on the outside. So the square root of 36 is the same thing as 6 on the outside of the radical. Same thing here. 16 is the largest perfect square. So square root of 16 is 4, so I can put that on the outside. The largest perfect square that can go into 50 evenly is 25. Square root of 25 is 5, so I can put that on the outside. So if I look at this example, 16 times 6, 16 is the largest perfect square that can go into 96. If you're like, man, how do you know this off the top of your head? You don't have to. You know it's the square root of 96. So I would start with look at your perfect squares. So you know your perfect squares, you have 1 times 1 is 1, 2 times 2 is 4, and so forth. So if I know 96 falls somewhere in between these two numbers, I will go ahead and take 96 and divide it by 81, divide it by 64, and just keep going down until you get a whole number. And once again, when I divide 96 by 16, I get 6, which means 16 can go into 96 evenly, and it can go in there 6 times. So I would rewrite 96 as 16 times 6. The square root of 16 is 4. Now, if I look at the square root of 200, that falls in between 196 and 225. So then you take 200 and you divide it by 196 and you get a decimal. Divided by 169, you get a decimal, and you just keep getting a decimal until you get to 100. Which we know the square root of 100 is 10, so I can rewrite this as 10 square root of 2. And where the 2 comes from, once I keep dividing and I try to keep dividing until I get a whole number, which shows me that that perfect square can go into that number evenly. When I divide 200 by 100, I get 2. So that means 100 times 2 is 200. So that's how I rewrote 200. And then when we look at a square root of 147, it's like, what happens if you have a number already out front? So go ahead and take 147 as it falls in between here, divided by 144, 121, and 100, and keep going. And then you get 49 eventually. And once you divide it by 49, 147 by 49, you get 3. So that's why I wrote 49 times 3. Now think about what the square root of 49 is, which is 7. So, traditionally I would write 7 square root of 3. But you already have an 8 out there. So you need to take that 7 and multiply by whatever you already have out there, which is 8. So you'll get 7 times 8, which is 56, square root of 3. And if you look here, I have a radical in all of these answers. So all of 3 of these answers are irrational answers.